in the right way. You want to do it in the test booklet, that's fine. Just do it in something that is shockingly different from the color you used originally. Okay? And I am counting this as a quiz grade because I really want you to do the corrections. I want you to do them well. Folks that came in yesterday during lunch, we get a lot of corrections done. We're good. I'm available today during lunch and Thursday during lunch, but not Friday. Friday is when it's due, so get this under control. All right, so that's test corrections, that's lunch support. Homework, hey, homework tonight. Everyone is going to do, I'm just so tempted to come over here, it's not just you. Everyone is going to do assignment number 23 on page 66. Good news, it's only one question with 812 parts. No, not 800, is it not page 66? I may have just lied to you about the page number. It's assignment 23. I think I lied about the page number. It's assignment 23. Somebody help me. Where is it? What page? Is it 61? No, 47. I know what happened. Assignment 23, page 47. Okay, lack of sleep will get you. All right, so yesterday we started talking about derivative rules. The most important one that you need to know, and you guys are going to get practice with this in just a second. And Karina, if I'm over here, can all the friends at home see me? Mm-hmm. Okay, the power rule. If you have something raised to a power, I want to get some hands on this. How does it work? What do you do to find the derivative? I see Henry, I see Diego, I see Marilyn, I see Gonzalo. Diego, what's the derivative? Of that one? In general, how would you find the derivative using the power rule? What do? You bring down the power, and you reduce the power by 1. And we're all going to say that on the count of 3. Okay, the power rule says 1, 2, 3. If I have x to a power, what do? You bring the power down and reduce the power by 1. All right, so easy then is something like this. Oh my God, how easy, how easy. Derivative of x to the 4th, everyone's going to call it out right now. What is it? 4x to the power 3, love it. Now, where things start to get a little bit wonky for some of you is going to be when I say find the derivative of x.
1x to the 1/2.
Not 1x to the 1/2. This is a power rule, but I'm being tricky. It's x to the 1.
Oh yeah.
Power rule says bring that power down, reduce the power by 1, you get 1 times x to the 0. But x to the 0 we know is 1. And if you're not sure, there's an exponents poster in the back corner over there next to Henry and Sylvia. Sylvia, you can thank me later. Okay, now things start to get a little bit weird for all the friends when we get to problems like derivative of 1 over x, and they're like, how is that a power rule question? Is it a power rule question?
Yes.
Okay, Jeanette, why is this a power rule question?
Because you can make it to x to the negative 1.
I'm rewriting, now pay attention to my notation here. I'm rewriting 1 over x as x to the negative 1 power. I still have to find my derivative. Now if I'm going to use the power rule says bring that power down, reduce the power by 1. This is a good answer, the best answer. Negative 1 over x squared, and I hope everybody's okay. Okay, things start to get a little bit wild when we start dealing with things like, derivative of the cubed root of x. Have a quick conversation with somebody near you. How is that a power rule question?
Is 1/3.
Head on though, how are you feeling about this one?
Negative.
Do you see it as a power rule question? Do the friends around you see it as a power rule question? Somebody help them out.
1/3. Just write it. Minus.
Okay, head on though, help me out. How are you going to find derivative of cubed root of x? What are you going to do?
Change it to x.
That's very girly if I head on though. I don't know what his voice sounds like, but it doesn't sound like that. Okay, head on though. How are we going to find derivative of the cubed root of x? What are you going to do with the exponents here? Okay, cubed root of x. Jackie, who sometimes gets herself confused with head on though. What are we going to do?
X to the power of 1/3.
Okay, this is really x to the power of 1/3. This is an algebra 2 thing, not a calculus thing. Cubed root of x is the same as x to the 1/3. Now I take the derivative, and what are we going to get, Michelle?
1/3.
1/3 x to the negative 2/3 power, right? 1/3 minus 1 is going to be negative 2/3. I like that, but it could be better. Henry, what you got for me?
1/3 over x to negative 1/3 over x to the third.
Okay, I'm going to pretend you didn't start off by saying negative.
Yeah.
Okay, 1/3 x to the negative 2/3 means send this to the denominator now as a positive exponent. And I like this, but there's better. Marilyn, give me better.
1 over 3x, no, 1 over 3 square root of x.
The denominator tells you what root to take. So cube root of x squared. Oddly enough, Mr. Harper was just teaching this like yesterday in pre-calculus. Exponent stuff. Okay, so with all that said, I'm going to stop talking. I need to take attendance so I can keep my job. I may be losing sleep, but I'm not going to lose my job. Okay, 5 minutes on page number 7. Show me what you can do with these top 5. You can help anybody out that you need to. You guys are going to start at 9:09. Okay.
She was saying something else. Someone got this. That was like.
Oh, I know the biggest mistake that's gonna be made.
So do we need to find what are you talking about?
Because that's just
What number?
yes or no.
4x to the third.
Unless they're going to get to find a double derivative.
Oh yeah.
So you have to find that one first.
Oh my God, what ugly notation. On number 1, I just walked by somebody who has 4x cubed plus 3x squared plus 2x plus 1. And I don't love that. I am not going to award that full credit because I have no idea what I'm looking at. What is this?
And the prime of x.
This is f prime of x. You best label it, son. This is f prime of x. Now, I also don't love this because I'm asking for f double prime, or some people are still calling it f prime prime. That was yesterday's joke. F double prime in the ideal world is 12x squared plus 6x plus 2. How many of you guys have that? Uh-oh. 4x cubed, 3x squared, 2x plus 1, 12x squared, 2 times 3 is 6. Derivative of 2 times x is just going to be 2. J's. Henry.
So like the last one, 2x, since it's you drop down the 1, so it's 1 times 2.
Yeah.
And then it's gonna be x to the 0, so it's 2 times 1.
Right, x to the 0 is still 1, so this is just 2 times 1, which is 2.
Oh, okay.
Okay. All right, number 2. G of t is 5t to the 9th minus 3t to the e plus e squared. Find d dt. What does that mean? Means the derivative. But I've got to read the whole notation. Take the derivative of this function at t equals 0. So the first thing I want to see is my derivative. And the derivative of 5t to the 9th, power rule, should be, what is that, 45t to the 8th? Bring that power down, reduce the power by 1. I saw a whole lot of people skipping this next part. I think it's that we don't like this idea of t to the e power.
No.
But here's the thing. What does the power rule say?
You bring it down.
Bring the power down, and then
You subtract another one.
subtract the power. Subtract 1 from the power. That's all. I don't need to know that what e minus 1 is as a decimal. E is a number, so e minus 1 is what the new exponent is. Plus, now I need to take the derivative of e squared. And on at least 5 different papers, I saw 2e. It is not 2e. It's not 2. What I know is that, and I just heard it from over here, e is a constant, right? So what about e squared? E is a constant. It may not be a number that you know, right? 2.718. But if I square it, it's still a constant. So what's the derivative of a constant?
0.
0. So the derivative is 45t to the 8th minus 3e t to the e minus 1 plus e. To find g prime of 0, it's going to be 45, 0 to the 8th, minus 3e, 0 to the e minus 1. 0 to any power is going to be 0. We just get 0. Done and done. For number 3, j of x equals 3x squared minus 2x cubed. Find all values of x such that j prime is equal to 0. I saw most folks said, okay, I know what j prime is. Is everybody good with j prime?
Yeah.
What do we get? What's j prime? 6x.
Minus 6x squared.
Okay, good. What that tells me is that you guys know how to find the derivative. There is no doubt we know how to find the derivative. But I need more, Jesus. I need to know where is my derivative equal to 0, so make an equation out of it. Use your algebra skills. If 6x minus 6x squared is equal to 0, maybe I want to factor. And that means that 6x equals 0 or 1 minus x is equal to 0. We get x equals 0. We get x equals 1. How many guys honestly had that? 1, 2, 3. I thought I saw some more folks that had 0 and 1. Okay. Everybody's good with finding the derivative though? This is the part that's good? Okay. Setting it equal to 0, just because I said, go figure out where it's equal to 0, and now it's in algebra skills. Okay. Number 4, what I might do, h of x is equal to 1 over x. Maybe I'm going to rewrite that first as x to the negative 1. Square root of x is the same as x to the half power. Now take a derivative. H prime is going to be negative 1, x to the negative 2, plus 1 half, x to the negative 1 half power. H prime of x, your best answer, is negative 1 over x squared plus 1 over 2 square roots of x. That's the derivative. There are like 15 more derivative rules coming your way. We're going to get a chance to look at derivatives for like the sine function, the cosine function, even the arctangent function, Gonzalo, is coming our way. By the time you're done with me, you'll be able to find the derivative of pretty much everything. But for right now, where we are in the calculus course, these are the only things you have to worry about finding derivatives of. Andy, you okay? That's so sad. Henry.
So when it says 1 over 2x, I mean 2 square root of x,
Yep.
can that also be 1/2 over x to the 1/2?
1/2 over x to the half, that technically would work too. It's just a little strange. But that's okay. That's okay. All right. I think everybody's mostly okay with derivatives? Good. All right. So let's push. Now we get to the fun stuff. I have a new calculus vocabulary term for you. And we're going to spend the whole day today and part of tomorrow, and this is part of tonight's homework assignment, getting good with this new adjective. And the word is differentiable. What's the word again?
Differentiable.
Differentiable. Differentiable is an adjective. It describes the function. If I tell you, Sylvia, that a function is differentiable, all it means is the derivative exists. I can find the derivative. Just like if I use the word continuous, I say the function is continuous. What does that mean?
That it'll keep going.
Not that just that the function keeps going, but it says something specific about the graph. If the function is continuous, what do we know?
There's no hole.
There's no holes, no jumps, no breaks, no vertical asymptotes. That one word says it all. It says I can draw the function without picking my pencil off the paper. It says that the function is defined, the limit exists, and the limit and the function have the same value. Differentiable is just a different word. So a function f is said to be differentiable at x equals a if the derivative exists. Since a derivative involves limits, in order for a derivative to exist, we need the following to be true. What we need is this. The definition says we need f prime of a to exist. Well, this word exist we normally use with like limits. What does it take for a limit to exist?
Has to be equal on the left and the right.
The limit from the left and the limit from the right have to be equal to each other, right? Well, why would I use that idea of existence with a derivative? Well, how do we find a derivative? What's the formula that you guys know? Oh, awkward
Oh,
silence.
f of x minus, right? Oh yeah, f of x minus f of a over x minus a.
I like it, I don't love it. That's not good enough.
Limit.
The limit as x approaches a. If f prime of a is going to exist, that means that the limit as x approaches a of f of x minus f of a over x minus a has to exist. But here's the trick. Because we're talking about a limit, it is possible that this limit doesn't exist. It's possible that when you find the limit on the left and you find the limit on the right, you get different numbers. This is a problem for us. So when you say the limit exists, what you're really saying is that the limit as x approaches a from the left of the derivative and the limit as x approaches a from the right of the derivative have to be the same. This is the big calculus, big idea here. A function is differentiable. It means that the limit, that the derivative exists. Because the derivative is built on limits, I need these two things to be equal to each other. Yeah, Henry.
So it's never mind. Oh, I thought one side was prime, the other side was.
No, they're both prime. We're looking at the derivative in both cases, Evel.
What's the difference between derivative of being the same on both sides and just making the function continuous?
What's the difference? Oh my God, you are brilliant sometimes. That was one of those times. That was one of those times, Evel. What I heard you just say is, what's the difference between saying the derivative exists and that the function is continuous? And I want to show you an example of a function that is continuous but not differentiable. Okay? Good. So with that said, let's keep going. Let's keep going. Exhibit A. I need you to please graph for me the graph of f of x. F of x is going to be the absolute value of x. Give me a good sketch. Label your points carefully. Give me a good graph. Don't get all OCD on me though. There's the graph of the absolute value of x. A nice parent function. If I said, let's pick a point, this point right over here, at x equals 2, and I asked you to find f prime of 2, what is it that I'm asking?
Find the derivative.
Find the derivative. What am I really asking though? Derivative is shorthand. Derivative is shorthand for something important about this graph. Derivative is shorthand for slope. Right? What's the slope of the tangent line? If I were to draw a little tangent line over here at x equals 2, what's the slope?
1.
It's 1. What if I picked the point up here, where x is equal to 3, and said, hey guys, go find f prime of 3. What's f prime of 3? 1. What if I picked a point over here, like -2, and said, hey friends, go find f prime of -2?
One.
What's the slope over here at -2? Not 1.
Negative 1.
It has to be -1. What about the slope over here? -1. I don't even know what that number is, but I know that f prime, wherever I am over there, is going to be -1. Do those derivatives exist? Are we able to find those derivatives? Are we able to find those slopes? Absolutely. We would say then that the function is differentiable. The derivative exists here. It exists here. It exists here. It exists here. It seems to exist everywhere. There is a special place worth examining, though.
Origin.
The vertex, the origin. Vertex are usually reserved for parabolas, but everyone's talking about this point over here?
Yes.
Okay. If I ask you to find f prime of 0, we're about to experience a problem. What is f prime of 0? What's the slope there? Some people are going to say, well, if I drew a tangent line, I think it would have a slope of 0, right? But here's the problem. When you make a tangent line, you actually start not with 1 point, you start with 2 points, right? I would say, what's the limit as x approaches 0 from the right of f of x minus f of 0 over x minus 0? I pick a point over here, and I ask you guys to find the slope of the line connecting those 2 points. And that slope there is 1. What if I move this point closer?
1.
Closer? Always 1, right? But what if Jose said, let's pick a point over here. Let's look at the limit as x approaches 0 from the left of f of x minus f of 0 over x minus 0. What are we going to get for the slope now?
Negative 1.
-1. The limit as x approaches 0 from the right of that derivative is 1. The limit as x approaches 0 from the left of that derivative is equal to -1. Guess what?
They don't equal.
They are not equal to each other. We have a fancy word for this.
Differential.
Well, they're not equal to each other. That means that the limit doesn't exist. If the limit doesn't exist, these two things mean that the limit as x approaches 0 of f of x minus f of 0 over x minus 0 does not exist. Our fancy way to say this, f is not differentiable, and be specific, at x equals 0. All the other points on the graph were fine. The function was differentiable everywhere except over here at x equals 0. This sharp point that you guys called, somebody said the origin, somebody said the vertex, there's a word for this sharp point. It's called a cusp, C-U-S-P. Tell somebody near you what the word is. Okay, say it like you're an angry German. Cusp. Okay, if you're not spitting when you say this, Adrian, you're saying it wrong. Say the word right. Cusp. It's a cusp. You have to spit at the end. Cusp.
Oh, don't be cussing.
Not cussing. That's different. That's different. Now, here's what I want to do, just to push your thinking a little bit. I want to make a graph over here of the derivative. We found the derivative over here is -1, over here it's -1, over here it's -1. What I want to do is I want to graph those points. What you guys were telling me is that the derivative is always -1. As long as I'm on this part of the graph. What happens if I'm on this part of the graph? What's the derivative? +1.
1 over, oh my god.
What happens at x equals 0 though?
The cusp.
It's a cusp point. So do I if I fill in this point over here, what you're saying is that the slope at 0 is -1. That's not true.
Wouldn't the circle have to be open?
It has to be an open circle. The derivative does not exist at this point, but a point just to the left of it, it does. What about up here? Another open circle. Anybody recognize that graph?
Yeah.
Everybody should recognize this graph. What graph is it? Jeanette, what's the graph?
Oh, I have a question.
Oh no, you always do that to me. What's this the graph of?
What over
Marilyn, what's this the graph of?
absolute value of x over x?
The derivative of absolute value of x is the absolute value of x over x. Jeanette, what was your question?
Why does it matter if it's an open circle or a closed circle?
Good question. If you have an open circle, what you're saying is at x equals 0, the graph is not defined. If you put in a closed circle, you're saying at x equals 0, the y value is -1. And because the graph is not differentiable, you have to go with the open circle. All right, let's fill in the notes here at the bottom. All right, for this graph, we can write the derivative of f of x as, what was that derivative again?
1.
Not 1.
0.
Uh-oh.
Absolutely.
It does not exist.
Based on the graph, the derivative is the absolute value of x over x.
Oh.
The derivative does not exist where?
X equals 0.
At x equals 0, because, I'd say because the graph has a cusp point. Graph has a cusp point. We can also say that the function is not differentiable. Right? I would prefer that we go with the phrase not differentiable. Or we can say that the graph of f of x is differentiable. I know I just missed a line. Go with me. The function is not differentiable at x equals 0. Where is the function differentiable? Everywhere else, right? The derivative exists everywhere else. So I'm going to say from -infinity to 0, and from 0 to infinity. Eva.
How do you spell cuss?
C-U-S-P.
Oh.
Cusp. All the friends mostly okay? All right, if I can get everybody up on your feet, please. You're going to be at the top of page 9. Top of page 9. And let's get you guys on your feet. What if you
If I call somebody a cuss, would that mean they don't exist?
It means that their derivative doesn't exist. Get it right.
Okay.
All right.
I always move over here. I was like, oh, you're not the little person.
All right, Karina, how are we looking? Okay. All right, BC friends are taking the quiz. Everybody else, we're good. Hey, Zeus, you okay? Looked like you needed to whisper something to Adele. Adele, no idea what you're doing over there. Okay, so in order for a function to be differentiable, some textbooks, instead of using the word differentiable, they say smooth. Smooth. They say a function is smooth. That is the same way of saying function is differentiable, that the derivative exists. Okay? So in order for a function to be differentiable at a point that is smooth, the function has to first be continuous. You have to have continuity. There can be no cusp point. Show me your cusp point.
No, that's
Cusp point. Now, I know we just looked at the graph of the absolute value of x, but could there be other cusp points?
Yeah.
Like what? What could those other cusp points? Other cusp points, they could look like this, right? If it is sharp, anything that is not smooth means you're not going to be differentiable. Smooth. We want to think smooth. Also vertical tangent lines. So let's look at this graph over here. The function has to be continuous. Graph number 1. Are we going to be differentiable?
No.
Differentiable everywhere? Graph number 1?
Not everywhere.
Not everywhere. Let's get some hands on this. Where is a place where you know the function is not going to be differentiable? Jackie?
Oh, right there at the little x equals -4. -4.
At x equals -4, why not here?
It's not point.
It's a, be specific, cusp point. Anywhere else on this graph where your graph will not be differentiable. There's another place. There's another place. Sylvia?
X equals 0,
Why?
because it's not continuous.
The function is not continuous there. To be differentiable, you have to first be continuous. Okay, talk to somebody near you, explain to them the two reasons, two places where this graph fails to be differentiable and why. Have a quick conversation.
And x equals 0 because it has a widow's peak, and then and x equals 0 and also
All right, friends, let's bring this back together. Bringing it back together on 3, and 2, and 1. Okay, there's another thing that we look for where differentiability fails. Can you guys show me a vertical tangent line? Vertical tangent line. It's so funny to look around the room and to see what's happening. Some of you are doing this, which is not vertical tangent line, that is vertical asymptote. Some of you are doing this. Sad panda if you're doing this, because this is a horizontal tangent line, vertical tangent line. Show me a vertical tangent line. I need a tangent line that is perfectly vertical. What's the problem with slope and vertical lines?
tangent.
No, not tangent. What's the problem with vertical lines and slopes? Something you've known since Algebra 1. Andy, what do you know? Something about the slope of a vertical line. Somebody help her out. Sylvia, help her out.
Perfectly vertical line is 0. Or no, it's undefined.
The slope is undefined. So if you ever have a tangent line that is perfectly vertical, you're not going to be differentiable. The derivative won't exist. Okay, so look at these 3 graphs. Anybody see a place where there's going to be a vertical tangent line?
Yes.
They're hard to see. In fact, at this point, you guys can sit down if you want to look at your notes. Are there any places where you're going to have a tangent line that is perfectly vertical? They're hard to see. It might be helpful to take like a pen or a marker or an index card and imagine those different tangent lines. Anybody find a tangent line where it is perfectly vertical? Garrison, where do you see a vertical tangent line?
For the graph on C, x equals -1.
Okay, the graph on C. Do you mean the third graph?
Yeah.
Okay, so you're saying over here at x equals -1. Is everybody okay with that? Yeah. It's hard to know for sure from the graph if you have a vertical tangent line. Normally we'll tell you, but I see this behavior. This is making me think, this is a vertical tangent line. So let's add that one into your notes. Okay, this guy over here is vertical at x equals -1. Anybody else see any vertical tangent lines anywhere? Jose, where do you see one?
And the first one between 2 and 3.
On the first graph, if I look at this very first graph and I take my marker, it looks to get perfectly vertical somewhere between 2 and 3. I don't know exactly where that point is, but visually, are we okay?
Yeah.
So the test for differentiability, I need you to check first for continuity. Is the graph continuous? The second thing you're going to look for, do you have any cusp points? And the last thing you're going to look for, vertical tangent lines. Julissa.
You know how the cusp is either a pointy
Yeah?
or would the vertex of that be considered a vertical tangent line?
Which one are you looking at? Which graph?
The first one.
The first graph over here. So over here, it wouldn't be a vertical tangent line. This is just a cusp point. If it's pointy. Yep. Yeah, go for it.
A vertical tangent line can only be one point, right? So we just get the point when writing your answer.
So I think I know what you're asking me. Let's try this next one. Okay, so on the bottom of page 9, there is a graph, and I just want to see how visually you're doing here. Number 9, tell me where the graph of x fails to be differentiable, and tell me why it fails to be differentiable. You've got the graph in front of you. Where does it fail to be differentiable, and why does it fail to be differentiable?
So if it has any of these 3, it means it fails.
Then it means that the function is not going to be differentiable at that point.
Just at that point, right?
At that point. We're describing the function at a point.
Why is that?
Okay.
You know what?
You took it's not.
When it's round, it doesn't count as
Yeah, it's wrong. But you know,
why is that?
because there's like
Correct. We're saying that if the graph has a vertical tangent line, then it is not differentiable.
no.
All right.
Like
All right, friends, show me in your fingers, please. How many places will this graph not be differentiable? How many places does the derivative not exist? It looks like 5 over there. 2, maybe 3. 2, 2, seeing a lot of 2s. 3. Okay, and Rebecca, give me one place you know for sure the graph is not differentiable. At x equals -1, because why? F of x, not it, f is not continuous. I agree. There's another place. Sheila, do you see another place where the graph's not going to be differentiable? At x equals 2, because has a cusp point, right? Because f of x has a cusp point. Now, some folks were saying that there's a third place. If there's a third place, where is this third place that we're seeing? Henry, where do you see it?
the vertical asymptote.
No.
Not vertical asymptote, vertical tangent line. If you had a
Oh,
tangent
yeah.
line that was perfectly vertical,
Yeah, vertical tangent.
where do you see a vertical tangent line?
In the left side. The left. No.
This is the left, Henry.
Yeah. I don't know.
Okay, does anybody see any other places where the graph is not going to be differentiable? We look for 3 things. Not continuous, cusp point, vertical tangent line. These are the only 2 places. So where are we differentiable? The graph is differentiable, I would say, on the interval -4. I don't want to say negative infinity because I don't know that this graph goes on forever. From -4 up until -1, parentheses and brackets. Parentheses. And then from -1 up until 2, parentheses and brackets. Parentheses. Otherwise, you're saying you are differentiable at 2. And then finally, from 2 to 4. This is it. Yep.
Oh, the point, you know, where the point is still, does that mean anything?
Well, we already knew the graph wasn't continuous at -1. This is just even more evidence that it's not continuous. Yeah.
How come on -4 you put the bracket, but on the other 4 you didn't put the bracket?
Yeah, I was being sloppy. There's some argument that really I should be using parentheses in both places. We're not going to worry about that right now. Okay, we got 11 minutes left, which is not exactly how much I wanted, but we're going to make this work. Because I want you guys to be set up for success in tonight's homework. Okay, just real quick, completely on your own, no help from anybody. Top of page 10, there's one problem. You've got 1 minute. This is a fair AP question for me to ask you. Don't get help from anybody. The graph of a function f is shown below. At which value of x is f continuous but not differentiable? Continuous but not differentiable. You guys have 10 more seconds to lock it in. And 5, 4, 3, 2, 1. All right, time to lock it in. How many of you guys are going to go for A? B, C, D, E? No idea. Thank you for the honesty, Henry, and Sheila, and other that will remain nameless. Okay, majority seems to go with A. As soon as that happens, they'll be listening. I'm looking for the function to do two things at the same time. Number one, continuous. Second, not differentiable. So the question you need to ask yourself at A, is the graph continuous?
Yes, sir.
Absolutely. Is it differentiable?
Well, yes.
No,
I mean, no.
because there is a cusp point. So you're continuous, but you're not differentiable. Why don't we pick B?
It's not continuous.
The graph is not continuous. C?
It's continuous.
Continuous and differentiable because the graph is smooth. I see you, Jeanette. Hold on. At D, don't pick D. I'm not continuous. At E, don't pick E. I'm continuous and I'm smooth. I'm differentiable. Jeanette.
Will we be able to do this without a graph?
High five. I just can't reach you. Jeanette, going to Brown. Here we go. It's time to take the training wheels off your differentiability bicycle.
Great.
Yay! And we're just going to remember this as Jeanette's fault. All the problems we've looked at for the last 20 minutes or so, you had a graph in front of you. If you have a graph, you look for three things. Is the graph continuous? Do you have any cusp points? And do you have any, what's the last thing? Vertical tangent lines. No graphs now. When it comes to a problem where there's no graphs, there's like this nice little check sheet down here that you can look at when you're working on the homework tonight. But let's just jump into it. Let's jump into the deep end of the swimming pool here. Okay. No, you're not going to drown. I'm a lifeguard. I'm much better with the unconscious victim. So here's what the problem's going to look like. It's true, I am. I've got this piecewise function. I don't know what happened there. That's supposed to be f of x. F of x is negative 2x squared plus 6. For x less than 1, k over x squared plus 1. If x is greater than or equal to 1, there is no graph here. I don't expect you guys know what the graph looks like. But let's look at part A. Determine the value of k that will make f of x continuous at x equals 1. I bet most of you would know exactly what to do with this, and if you're in that category, just go for it. Just go for it. In order for the function to be continuous, find f of 1 for me. What's f of 1? I use the bottom function, k over 1 squared plus 1, we get k over 2. That exists. Next thing, limit as x approaches 1 from the left. From the left means less than 1. I look at negative 2x squared plus 6. This is going to be negative 2 plus 6. That should be 4. The limit as x approaches 1 from the right should be k over 2. My function is defined at 1. The limit as x approaches 1 from the left exists. The limit as x approaches 1 from the right exists. What's the just right value for k? 8. Right? You guys can just see that it's 8. Right? Because what you need 4 to be equal to k over 2, so k is equal to 8. If k is equal to 8, f of 1 is 4. Limit as x approaches 1 from the left is 4. Limit as x approaches 1 from the right is 4. Everything works for continuity. Are we good?
Yeah.
Continuity is good. Now for the push. For this value of k, so 8, I'm going to replace k with 8 now. Determine if f is differentiable. To figure out if f is differentiable, you have to look at the derivatives. You have to know. The question is, does f prime of x exist at x equals 1? If you had a graph in front of you, this would be easy. There is no graph. So here's what we do. We look at the limit as x approaches 1 from the left of f prime of x. We look at the limit as x approaches 1 from the right of f prime of x. One of these should be easy.
The top one, the bottom one.
These are our choices, yes. The top one and the bottom one. I'm asking you to look at derivatives. One of these, you should know the derivative just by looking at it. Very little brain space required here. And that should be this top one, derivative of negative 2x squared plus 6. What's that going to be? Negative 4x. So I'm asking you to find the limit as x approaches 1 from the left of negative 4x. Maybe you want to put a little note. This guy here is the derivative. Well, what is that limit? Limit as x approaches 1 from the left of negative 4x is just negative 4. The limit as x approaches 1 from the right, though, of the bottom piece, sad panda, not power rule. This is not something that you know yet unless you've looked at the quotient rule, and some of you do weird things like that. What you would have to do is go back to the old school definition. Limit as x approaches 1 from the right, f of x minus f of 1 over x minus 1. You're going to have to do it the old way. Well, f of x is 8 over x squared plus 1. F of 1 is 8 divided by 1 squared plus 1. I think, what is that, 4? In the denominator, x minus 1. Take a minute on this. See what you can do with that limit. Yeah. What is that? Oh, just it was supposed to be a comma to separate the two pieces. Thank you for making me a better teacher, Adele. We need to know how to evaluate this limit. This is Unit 1 skills. There's going to be lots of opportunities to practice. I might focus on that fraction. 8 over x squared plus 1 minus 4. Get a common denominator. The common denominator is x squared plus 1, so I'm going to multiply by x squared plus 1 over x squared plus 1. If you do that correctly, you're going to get the limit as x approaches 1, 8 minus 4 times x squared plus 1. I'll get out of the way. Over x squared plus 1 divided by x minus 1. I multiplied the 4 by x squared plus 1 over x squared plus 1. They now have the same denominator. 8 minus 4 times that, if I distribute, we get 8 minus 4x squared minus 4. Good news, 8 minus 4 is 4 minus 4x squared. I'm not canceling out yet. We are not canceling out the x squared plus 1s. The x squared plus 1's not a factor. What I can do, though, 4 minus 4x squared, I can take out a 4, and that's going to leave 1 minus x squared. And 1 minus x squared is a difference of squares. We get 1 minus x times 1 plus x. So let me go back over here. Your new problem is limit as x approaches 1 from the right, 4 times 1 minus x times 1 plus x divided by 1 plus x squared. If I had room, I'd say all this divided by x minus 1. But thanks to your Algebra 2 skills, you know that's the same as multiplying by 1 over x minus 1. What happens now? The x minus 1 down here, the 1 minus x up here are opposites of each other. So that leaves behind a negative. Take that limit as x approaches 1 from the right. Give me just 1 second. Negative 4 times 1 plus 1. You get 8. You get, well, hold on. We're going to get negative 8. X is getting close to 1. Negative 4 times 1 plus 1. We get negative 8 in the top. In the bottom, 1 plus 1 squared, we get 2. Negative 8 divided by 2 is negative 4. Let's wrap it up. What does that mean?
It's differential.
The limit as x approaches 1 from the left of the derivative was negative 4. The limit as x approaches 1 from the right of the derivative, negative 4. So I'd say, therefore, f prime of 1 exists or f is differentiable. Tonight's homework, you're going to get some practice with proving differentiability. If I was going too fast, I'll email you guys my notes for this problem as well as the practice problem that comes after it. And I will be available at lunch if you need me.